Imagine a spacecraft with no engine, no combustion chamber, no ion thruster, no enormous tank of fuel. Nothing is ever expelled from the back of the vehicle. And yet, this craft can accelerate at an almost unimaginable rate. It can change direction without slowly rotating. And, strangest of all, it can stop on a dime. Every spacecraft humanity has ever built obeys one basic principle. Throw something backward and you move forward. Chemical rockets throw hot gas. Ion engines throw charged particles. Even a solar sail pushes against light. But the ship in this story pushes against nothing at all. Or rather, it pushes against the structure of empty space itself. The engine is not attached to the spacecraft. The spacecraft is the engine. At the center of this story is a mathematical object, the three-dimensional seed, 4 geometric sheets, a seam graph, and an internal symmetry group. To understand how such a cruiser might work, we first have to abandon one of our deepest intuitions, the belief that empty space is truly empty. In classical physics, a vacuum is simply the absence of matter. Remove every atom, every particle, every photon, and we say the region is empty. But quantum theory paints a very different picture. Quantum fields remain present even in their lowest energy state, the vacuum state, and the vacuum does not behave like a perfectly still ocean. Every field fluctuates. Each mode of the field carries a zero-point energy. 1/2 h bar omega, sum over all possible frequencies, and the result is not even finite. Taming it requires regularization and renormalization. But one extraordinary fact survives the calculation. The geometry of a boundary can change the vacuum's energy. This is the Casimir effect. Place two conducting plates extremely close together. Between the plates, only certain wavelengths fit. Outside, a different collection of modes is available. The mismatch produces a real, measurable force, a negative pressure that pulls the plates together, scaling as the inverse fourth power of their separation. The Casimir effect is real. It has been measured in the laboratory. But in every ordinary Casimir experiment, the geometry is passive. Two plates simply sit there. They do not twist into one another. They do not exchange their roles. The seed is different. It is not a pair of plates. It is a geometric machine. The classical seed is a triple, a geometric body, a seam graph, and a symmetry group. The body, I3, is assembled from 4 orbifold sheets, and these sheets are not merely placed side by side. They are sewn together along a structured seam system. The graph, gamma 3. This is the real object. 4 spindle-shaped sheets, threaded along the body diagonals of a cube, meeting along the white seam graph. In the spacecraft interpretation, the sheets are the vacuum chambers, and the seams are where competing boundary conditions collide. The third component is a finite symmetry group, pi3, generated by 3/4 turn operations, pi x, pi y, and pi z. Each generator rearranges the internal geometry of the seed, repositioning the 4 sheets relative to the seam network. And crucially, the group is noncommutative. Pi x followed by pi y is not the same as pi y followed by pi x. The seed remembers the path taken through its configuration space. So here is the full anatomy of the cruiser. The body is the engine chamber. The seam graph is the vacuum pressure network, and the symmetry group is a geometric transmission. Now zoom in on a single edge of the seam graph. Near this edge, several portions of the orbifold sheets approach and meet. Any quantum field living here must satisfy boundary conditions inherited from all of the adjacent sheets. So the allowed vacuum modes depend on the local seam geometry. We describe the resulting vacuum stress by a renormalized stress-energy tensor. And near the seam graph, that stress need not agree with the stress of the surrounding, ambient region. This difference is the seed's analog of Casimir pressure. But instead of appearing between 2 flat plates, the stress is distributed along a graph. Every edge carries its own vacuum stress profile. Every vertex acts as a junction, and every closed cycle behaves like a resonant vacuum channel. All of it can be packaged into a single assignment. To each seam edge, an effective vacuum stress. In a perfectly symmetric configuration, these forces balance. The net force is zero, exactly as it should be. Internal forces alone cannot accelerate a closed system. The seed may contain enormous internal vacuum pressure while remaining perfectly motionless. So Casimir stress alone is not enough. To turn the seed into a cruiser, something must dynamically change the boundary conditions. That something is the group. Choose an element, pi, of the symmetry group and act. Watch closely. This is not a rigid rotation of the whole object in space. The action reconfigures the seam system. Gamma 3 becomes pi of gamma 3. And because the seam geometry has changed, the allowed quantum modes change with it. The vacuum stress state transforms. This is the central speculative step of the story. The Casimir effect tells us that vacuum energy depends on boundary conditions. The seed adds a finite, noncommutative system for changing those boundary conditions from within. A quarter turn about x could compress one family of vacuum modes while opening another. A turn about y could redirect the stress into a different seam cycle. A turn about z could close the cycle in a new, stable configuration. So the propulsion sequence is not turn the engine on. It is a word in a noncommutative group. The pilot does not throttle fuel. The pilot chooses a path through the group. But we must be scientifically careful. For a closed system in flat spacetime, internal Casimir forces obey momentum conservation, and no reactionless drive has ever been demonstrated. The stronger hypothesis is that the seed does not merely redistribute force inside a fixed background. Its sheets and seams alter the effective geometry through which the whole craft moves. The seed is not pushing through space. It is changing the local rules by which motion is measured. Suppose a conventional spacecraft accelerates hard. A passenger resists the change in motion. Inertia slams them into their seat. At extreme accelerations, no human body could survive, no matter how powerful the engine. So the most important feature of the seed cruiser is not its thrust. It is the possibility of shared, geometric acceleration. Let omega be the region the seed encloses. The speculative goal is to make the effective acceleration nearly uniform across that entire region. The same for the hull, the air, the pilot, and the glass of water on the table. If everything inside follows the same locally modified geometry, then enormous coordinate acceleration might occur with almost no internal forces. Inside, the cabin stays calm. The water in the glass barely trembles. Outside, the stars begin to streak. An ordinary rocket obeys F equals ma. The seed cruiser attempts something different, modify the effective geometry that determines the acceleration in the first place. The controlling object is no longer a force vector. It is the internal state of the seed itself. Now suppose the cruiser is moving at enormous speed. A conventional spacecraft would have to flip around and burn its engines through a long, brutal deceleration. But the seed has inverse operations. For every group element pi, there is an inverse that undoes it. If the moving state was created by a word, then the stopping sequence is that word's inverse, with the order of operations reversed. This is not pressing the same buttons backward. The noncommutative structure remembers the exact sequence, and the craft stops by geometrically undoing the state that produced its motion. The seam cycles reverse. Compressed modes expand. Expanded modes contract. From outside, the deceleration looks nearly instantaneous. The ship races across the sky, the seams flash in reverse order, and then it is simply motionless. And once again, the passengers survive only if the entire interior shares the same transition. The hull cannot stop first while the people keep moving. The craft does not stop its contents. It stops as one geometric object. The seed has three distinguished generators, pi x, pi y, and pi z, three natural control directions. Rather than mounting engines around the hull, the cruiser steers by composing internal operations. And because those compositions do not commute, turn right then rise, can differ geometrically from rise, then turn right. The vehicle is controlled not by ordinary vector addition, but by a noncommutative navigation language. A flight path becomes a word in the group. The pilot does not enter coordinates. A navigation computer searches for the group word that produces the required vacuum stress evolution. Destination to group word to geometric motion. The spacecraft is flown by solving a problem in geometry. So, what in this story is real, and what is speculative? These things are real. Quantum fields fluctuate, even in the vacuum. Boundary conditions alter the allowed modes. Casimir forces have been measured in the laboratory. Vacuum stress is described by a renormalized stress-energy tensor, and geometry and topology genuinely shape quantum spectra. And these things are speculative, concentrating Casimir stress on the seam graph, reconfiguring that stress with the symmetry group, extracting net thrust from a closed system, and modifying inertia throughout the cabin. The Casimir effect by itself provides no known reactionless drive. Momentum must still be conserved. Any physically viable cruiser would have to exchange momentum with something. Radiation, an external quantum field, or spacetime geometry itself. The seed's role is not to pretend that an engine has already been built. Its role is to offer a new geometric stage on which the question can be asked. Instead of two static plates, 4 interacting orbifold sheets. Instead of a single cavity, a seam graph of coupled cycles. Instead of one passive boundary, a finite, noncommutative family of reconfigurations. The seed turns a simple Casimir cavity into a dynamical, geometric network. Return one last time to the spacecraft floating silently in space. No visible thrusters. A body of 4 interlocking sheets threaded by the glowing seam graph. At every edge, quantum modes are constrained. At every vertex, vacuum stress channels meet. Deep inside, the symmetry group waits in the identity configuration. Then the first generator fires, pi x. One family of seams brightens, then pi y inverse. The sheets reconfigure, the vacuum changes, and the cruiser begins to move, not because it threw fuel backward, not because it pushed on anything nearby, but because a geometric machine changed the boundary conditions imposed on empty space. At the destination, the seed performs the inverse word, and the craft stops. Perhaps the ultimate spacecraft will not burn matter. Perhaps it will not carry an engine at all. Perhaps it will be a piece of geometry whose internal symmetries decide how the quantum vacuum surrounds it. A vehicle that does not move through empty space, but rearranges empty space around itself.